All right, so for single replacement reactions or double replacement reactions, you only break up those compounds that are aqueous and are either ionic or acidic. So they have to be aqueous ionic or aqueous acidic to break them up. Yes?
If the next quiz you said either or grade, I don't want to use this one, so the next quiz is going to be like tomorrow or something?
My quizzes are always pop quizzes. You don't know in advance when they're going to be.
I was just asking because I'm going to be here tomorrow.
Oh, well. All right, so this is an ionic compound. You know it's an ionic compound because it's got a polyatomic ion in the formula. And it's aqueous. Therefore, it will break up. Okay? So to break it up, we just simply write the parts that you started with when we were first writing formulas from ions. We're just going back in the other direction. There's a silver ion right here. If it's an ionic compound, we have an ion here and an ion here. So we're going to write the separate ions. Silver, okay, we're going to find its charge number. And for that, we'll use the periodic table with oxidation numbers. There's silver. Silver only has a 1+ charge, so this is going to be silver plus. Aqueous applies to all the ions in the formula, so it's aqueous. And this 3 applies to everything in the formula, so there are 3 silvers.
Can you put it under it?
Put what under it? No, the 3 is a coefficient here. Has to be a coefficient. Okay? All right, now we're going to write the nitrates, NO3. If you don't know what the charge on a nitrate is, use your common ions list. There's nitrate, has a 1 negative charge. The aqueous applies to everything in the formula, so this is also aqueous.
This is the ionic or negative?
This is the complete ionic equation. You have to write that first. And the coefficient 3, since it applies to everything in the formula, that means we're going to have 3 nitrates.
Mr. Kevin?
Yes.
Like if it was 2 negative, something like that, would you put a 2 then a negative on it?
Yes. All right. Aluminum is a solid. It doesn't break up. It's not aqueous. It's going to stay the same. Okay. Aluminum nitrate. It's going to break up. We're going to have aluminum. It's going to be aqueous, but we need to know its charge. The periodic table with oxidation numbers will tell us the charge. There's aluminum. Has a 3+ charge. So we're going to put a 3+ after this aluminum. We're going to have 3 nitrates. This 3 outside the parentheses means that everything inside is times 3. Okay? So there are going to be 3 nitrates. Okay? And then we'll have this silver doesn't break up. It's not ionic. It's not acidic. It's certainly not aqueous. So we'll have 3 silver metals. Okay? And that's a complete ionic equation.
What about the charge on the first one?
What about the charge on the first one? This one?
No, the first aluminum.
Well, it doesn't break up. If it doesn't break up, it doesn't have a charge.
Why doesn't it break up?
Because it's not in a compound. It's by itself. Yeah.
Do you know how one single element by itself break up?
No. No. Not in this class. Okay? Alright. So that's a complete ionic equation. And to find the net ionic equation, all we're going to do is go through and find anything that is exactly the same on both sides. Okay? Well, now look at the silver here. It's got a 3+ charge and it's aqueous. But this silver doesn't have a charge and it's a solid. Those aren't exactly the same. Okay? The aluminum, this is a solid. This one has a charge on it and it's aqueous. Those are not the same. They have to be exactly the same. And the only thing that's exactly the same are these nitrates. Okay? The complete ionic equation includes those nitrates. They're called spectator ions. But the net ionic equation will take those out. And so you rewrite the equation. You must rewrite the equation without those. Okay? It's not enough to mark them out. That doesn't show what the net ionic equation is. You must rewrite it without the spectator ions. Okay? So that is the net ionic equation then.
Does that mean the same order?
Not necessarily. I mean, as long as they're all there, that's what really matters. Okay? All right, let's take a look down here at the combustion reaction. There are no aqueous compounds. There are also no acidic or ionic compounds. So nothing here breaks up. There are no ionic equations for combustion. There never will be ionic equations for a combustion reaction. At least not in this class. Okay? All right, let's look at a double replacement reaction down here. Okay? This is aqueous, and we know because there's a polyatomic ion here that it's ionic. This is aqueous. We know because it's a metal and non-metal, it's ionic. This is aqueous. Metal and non-metal, it must be ionic. But this was not aqueous. It is ionic, but it's not aqueous.